In Chapter 7, we're going to be looking at some states of matter and how those states of matter affect behavior, and also a little bit about what makes certain things be in a certain state. And so first of all, we're going to look at the properties of the three states of matter that we look at in general chemistry, and that is gas, liquid, and solid. And so they differentiate based on shape, the arrangements of the particles found in them, their density, and that's just relative to each other, the particle movement, and also what type of interactions or the strength of interactions. So in a gas will expand to fill whatever container you put it in, whether it's a balloon or a plastic bag or a compressed cylinder. It will get as big as it can in volume to fill that container. The particles are randomly arranged, disorganized, and they try to be as far apart from each other as they can. Very low density of particles in there. They're moving very fast, and there's negligible interaction between those particles, so hardly any interaction between those individual particles at all. A fixed volume in liquid is the difference between a gas and a liquid as far as shape and volume. It still takes the shape of the container, but the volume will not change. It has randomly arranged particles, but they're very close together, especially compared to gases. It has a high density, about 1 gram per milliliter. Moderate particle movement, they're still moving around, but not nearly as quickly as a gas, and the interaction between the particles is strong. A solid has a definite shape and volume, and that is you can put it in different containers, but the shape will remain the same and the volume will remain the same. And it has fixed arrangement, usually very, very symmetrical. So if you were lining up glasses in your cabinet, they would be in these perfect little rows of 4 by 4 or something like that. High densities compared to the other. This is the highest density of the three. And slow moving particles. In some solids even, it's just like more of a vibration than it is a moving around. And then interaction between particles is very strong, and so it's harder to break those interactions between solids than it is liquids, than it is gases. And so as you can see, there are several different characteristics that are different between those three states of matter. So if you look at this visually, then you can see that a solid has this geometric arrangement here. The liquid, see how close they are, but they are still kind of randomly moving around. And then finally, gases are going to be very far apart and not really interacting with each other very much. And whether or not it's a gas, liquid, or solid depends on the balance of the kinetic energy of its particles and the strength of the interactions. So how much energy is in the system and how strong are those particles attracted to one another. So this thing called the kinetic molecular theory of gases basically predicts how gases are going to behave. And there are certain rules that this states. And again, remember that this is typically in a perfect world. So a gas consists of particles that move randomly and rapidly. The size of gas particles is small compared to the space. So there's a lot more space between the particles than the size of the individual particles themselves. Gas particles have no attractive forces. That is, they really don't interact with each other when they're in a container. The kinetic energy of gas particles will increase as you increase temperature. So if you've got them in a container and you heat it up, the kinetic energy is going to increase if you increase the temperature, because they're going to speed up and they're going to start bouncing around even more. When gases collide with each other, they rebound in what's called an elastic collision. And in that type of collision, they really don't exchange energy, they just change direction. When gas particles collide, they exert a certain amount of pressure, okay? So as they are hitting something, just like if you hit a wall, there would be a certain amount of pressure, and if the wall doesn't give, then you are going to feel that, right? Where if you punch a pillow, then it could absorb that. So when gas particles collide with walls of a container, they exert a certain pressure, and that pressure is then transferred to that particular material of the wall. Pressure is the force exerted per unit area. So force divided by area. And the units of pressure that we use are millimeters of mercury, torr, pounds per square inch, or pascals. And so 1 atmosphere is the standard, the SI unit of pressure. And so all of these things, 760 millimeters of mercury, 760 torr, 14.7 psi, 101,325 pascals, or 101.325 kilopascals. You'll see that one as well. Those are all equal to 1 atmosphere of pressure.